Hi, I'm Marissa Krieg, and I'm in ITM 2010, Section 04. Today we're going to talk about data analytics, data mining, and cognitive computing. This is a political cartoon satirizing why we need data analytics, data mining, and cognitive computing. It says here that it would appear, Hopkins, that your gut feel was only indigestion. So it's kind of making fun of how he thought he knew what he was doing, but he actually needed to analyze and decide while using these tools. Data analytics is the science of using quantitative and qualitative processes to increase profit margin, productivity, and efficiency. Data mining refers to sorting through huge sets of data by using sophisticated software to uncover and detect otherwise overlooked patterns and relationships. Cognitive computing refers to a human-like way of processing data that takes into account the context of the data. I found this infographic to be interesting because it kind of shows the life cycle of data analytics. It shows how it all starts with a plan and then goes into the quality of the data you have and then refining the data to make sure it's going to be able to be used by your operations. Okay, so what we're going to talk about today are data analytics, data mining, and cognitive computing, but the summary, benefits, and challenges of each. This graphic shows the key components of data analytics: data modeling, business intelligence and reporting, extract, transform, and load, data migration, and data architecture and structure. Data analytics is the scientific process of examining raw data through quantitative and qualitative processes. It is used to increase businesses' profit margin, productivity, and efficiency. The data is organized in a way that can be used to find patterns, make inferences, and initiate improvements and modifications to the overall business structure. The process of data analytics is that the data is collected, stored, categorized, and then used to make inferences. The benefits of data analytics are that it allows one to make better business decisions, confirm or disprove current business models, structures, or theories, and can allow a business or company to achieve their overall business goals. As with most processes, there are challenges that come with data analytics. For a company to use data analytics effectively, they must formulate a strategy, which is difficult to do if you do not know what you are doing wrong in the first place. There could be an error in the categorization of the data, which could furthermore cause a flaw in the use of the data, and the data is not always accurate. I chose this graphic because I wanted to remind us that data analytics is the elephant in the room. Using it will help your business become much more than what it is. Data mining is configured of many separate disciplines, including statistics, visualization, algorithms, pattern recognition, machine learning, database technology, and other disciplines. Data mining refers to statisticians, also known as data miners, sorting through huge sets of data, which can be called big data. It uncovers and detects otherwise overlooked patterns and relationships through the use of sophisticated software. It intertwines methods such as artificial intelligence, database systems, machine learning, and statistics. It takes data and transforms it into something that can be used by companies and businesses. The benefits are that data mining can detect otherwise overlooked patterns in the data. It allows for a business to reconsider its current models or theories, discover new business structures, make new inferences, or update current business structure. Even though the data is not new data, the way that it is presented and organized is new and can help more than simply collecting more data. The challenges that come with data mining include that it does not create data. It uses previous or old data which could be of poor quality or not the same quality as the data is to be categorized with or compared to. There are many ways to use data, and some may overlap, and if used incorrectly, then the uses of the same data could contradict themselves. I found this picture to be interesting because it kind of sums up what data mining actually is. It's going through old and previously discovered data and using it in new ways. These are good examples of the key aspects of cognitive computing. They are all parts of machine and human interaction. Cognitive computing is the human-like way of processing data and problem solving. It takes the context of the data into account. For it to be effective, it must be adaptive and ever-changing, interactive to find out the needs of the user and population sample, itinerant and stateful to remember and apply what is worked with previously, and contextual to not only take on the data, but take it in a way that makes sense of it. The benefits of cognitive computing are that it gives context to data. It finds the best solution rather than simply the right solution. It makes judgments and decisions in a similar way to humans. Although there are many benefits to cognitive computing, there are also many challenges. Creating a computer that can act as though it is human is often difficult and can end up creating problems, so it must be closely monitored until all glitches are resolved. It is hard for a computer to keep up with the ever-changing lingo, and also applying context to data across many languages can cause some barriers. Cognitive computing can change the way that computers work. There are 4 dimensions that we need for this to work: perception, reasoning, relating, and learning. Thank you for watching. This is my work cited, and I hope you learned something today.